Good morning, guys. I'm Ritwik Dakore. I'm going to present a project on mobile price range detection prediction using machine learning. So let's go over the project summary. This data science project aimed to predict the mobile price ranges based on their specification using machine learning algorithms. The dataset consisted of various features related to mobile phone, such as battery, capacity, RAM, internal memory, camera quality, and other hardware specifications. The dataset was split into training and testing set and several machine learning algorithms such as decision tree, random forest, and SPM. The random forest algorithm was chosen as the final due to its high accuracy and F1 score. The project concluded that the predictive modeling can be effective for mobile prices detection and highlighted the importance of data pre-processing and feature engineering for improving model accuracy. So this is the GitHub link. So let's go over the problem statement. Company operating in the fiercely competitive mobile phone market aim to comprehend sale information regarding mobile phones and the underlying factors that affect their pricing. Their goal is to establish a correlation between various features of mobile phone, such as RAM, internal memory, etc., and its selling price. However, the focus is not on predicting the exact price of the device, but rather determining a price range that indicates its level of affordability. So in the dataset, we are given various data descriptions such as battery power, blue that means Bluetooth or not, clock speed, which is speed at which processor execute instructions, dual SIM, whether it has two SIM or single SIM, front camera, 4G, internal memory, mobile depth, mobile weight, processor cores, primary camera megapixel, pixel resolution, height, width, RAM, screen height, talk time, 3G or not, touchscreen, Wi-Fi, and price range. So let's go over first importing libraries and file reading. We will import pandas, NumPy, Matplotlib, and Seaborn for our project. We will mount the drive and then give the file path to read the file. So here we will read the mobile data and we will get the first five column from dot head and last five rows from dot tail. Then let's check the shape of our data set. It has 2000 rows and 21 columns. Then let's check the statistics of the data using .describe. Here is our data set. We can see the screen width and pixel height has minimum value of 0. Here we can see pixel height and screen width is 0, which is not possible in any phone. So we need to handle this error. So checking the observation having screen width as 0, there are 180 and observation having px height as 0, there are only 2. So we will drop this 2 observation. So then we need to handle these 180 errors. So we will handle it using the nearest neighbor imputation. Here first we will replace 0 with NaN so that we can implement KNN imputer. It is KNN imputer, which means that missing values are imputed using K nearest neighbor approach, where Euclidean distance is used to find the nearest neighbor. In easy word, it predicts the number using the previous data, the next number. So then we will import the KNN imputer from Scikit-learn. After transforming, we can check the mobile data shape, that is 1998 to 21, that is row and column. And then we will check screen width value as 0, there are 0. So we have handled this mismatch value. Here we can see the info. Here we can see that we don't have an object data type in our dataset, and we also have 0 null values in the dataset, which is good. And prices is our target variable. So here we will also check the null values. There are 0 null values, and we will visualize this null value using heat maps. So as you can see, there are no null values, so it is plain. And we will also check the duplicates. Luckily, we don't have any duplicates in the dataset. So let's go on and do an EDA. So let's look at our target variable count. Here we can say there is a target variable with value of 0, that is low, 1 is medium, 2 is high, and 3 is very high. Then we can visualize this target variable class distribution. We will label this low cost, medium, high, and very high. And after visualization, we can see it is almost divided equally. So then we will check the correlation of target variable, that is dependent variable, other independent variable. Here we can see this using graph. So here we have made a few observations. RAM has the strongest positive correlation with the price range, and we know that the mobile with high RAM are very costly. Thus, RAM sizes increases the price range also. Battery power also has the positive correlation with the price range. Generally, mobiles have high price come with the good battery power. Also, pixel height and pixel weight are positively correlated. 4G and 3G are highly positively correlated nowadays. Most of the smartphones has both type of option. Primary camera, that is PC, and front camera, FC, are positively correlated. So we can see column of mobile data, that is our data set, battery power, Bluetooth or not, clock speed, dual SIM, etc. So after the concluding EDA, we will move over to the univariate analysis of categorical columns. Here we will first move over to plotting the pie chart for binary categorical variable, whether it has Bluetooth or not, dual SIM or not, 4G or not, using single variable. Then we will continue with relation between RAM, battery power, pixel height, and pixel weight. Here we can see we have plotted the bar graph, and we have made observation that mobile having RAM more than 300 MB falls under very high cost category. Mobile having less than 1000 MB falls under low category. Mobile with battery power more than 1300 mAh has very high cost. Mobiles with battery more than 1200 and 1300 mAh falls under medium and high cost. Mobiles with more than 700 pixel height and width more than 1300 has very high cost. So we'll check the count of binary categorical variable by grouping price range. So we'll use dot group by price range, and we will visualize using the bar chart. Here we have plot a graph. Here we can see that each price range category has equal number of mobile phones having both supporting and non-supporting specification. We will make the list with n codes, check the number of codes. So then here we have made observation. There are very few mobile in price range 0 and 1 with lesser number of codes. Most of the mobiles in price range 2 and 3 are with high number of codes. So let's move to numerical feature is driving the price range mode. So first we will get the columns. We will prepare a list where we are using a popular feature. Here we have an observation that class 1 and class 2 battery power range is almost similar. Mobiles in very high price range, that is class 3, has less weight compared to other classes. Mobile having max screen height and width falls in very high price category. RAM has clear relationship price range. We saw that the correlation matrix also. So we will check with mobiles with both 3G, 4G, both with 3G and mobiles that don't have 3G nor 4G. So let's check the distribution of numerical columns and outliers. First we will get the column and plotting the box plot and distribution. We can see the data is well distributed and PX and FC headers have some outliers. So we will treat the outlier. Here we have treated the outlier. Let's move to the feature selection, where we will be selecting a few feature that has a direct correlation with the price range. Here we are selecting the features. We have selected the 12 highest feature with highest chi-squared statistics. That is RAM, PX height, battery power, PX width, mobile weight, internal memory, screen height, talk time, screen width, front camera, number of codes, and PC. So after selecting the 12 highest with the 12 highest variable, we will move on to the predictive modeling. Predictive modeling is nothing but the process of using statistical and machine learning techniques to analyze data and build models that can be used to predict future outcomes or behavior. It involves indicating pattern and relationship in the historical data and using this information to develop models that can be used to predict the future event or behavior with high degree of accuracy. It is nothing but using the last variable or the last data from the data set to predict the future. So like if I have data from 1, 2, 3, and it will predict the future, that is 4, 5, 6. It will learn the technique and move over to the predicting the future. Here we can see we are as a decision tree, random forest and ensemble tree do not require feature scaling. So we will be using xtrain and xtest, which are not scaled. We have printed xtext scale and xtrain scaled. So let us move to the first algorithm, that is decision tree classifier. Decision tree and ensemble method do not require feature scaling. So we will xtrain and xtest, ytest and ytrain. So decision tree with default hyperparameters. Here is the conclusion, and we will look at the conclusion of all the predictive modeling later. Here, after we use hyperparameters, second is random forest classifier. Here, with default parameters and with hyperparameter tuning. Also, we will look at this observation and conclusion later. Same with gradient boosting classifier with default hyperparameters and with hyperparameters. Here we can see the ROC curve, k nearest neighbor with default hyperparameters and with parameter tuning. XGBoost classifier with default hyperparameter and with hyperparameter tuning. SVM with default parameter and hyperparameter tuning. So let's look at the final observation from Adobe predictive modeling. So first observation of decision tree classifier. We can see before hyperparameter tuning, the training accuracy was 100% and test accuracy was 84%. Model is overfitted and the data does not generalize well. So we will tune it using hyperparameter. After hyperparameter tuning, the training accuracy decreased to 98 and test accuracy increased to 91. However, this will not be a good model for us. RAM, battery power, pixel height and width came out to the most important feature. Next observation was random forest. Before hyperparameter tuning, the training accuracy was 100 and test accuracy was 88. So after the hyperparameter tuning, it remained almost the same. Training accuracy 100 and test accuracy increased by 2, that is 90%. We can see a slight improved model, but overfitting is slightly reduced. Observation of gradient boost classifier. Here, training accuracy and after and before are almost same. Training accuracy 100 and test accuracy 89. Training accuracy remained the same 100% and test accuracy increased to 90%. So after k nearest neighbor, before hyperparameter tuning, the train accuracy was 75 and test was 59. Clearly, model has performed the very worst. We did hyperparameter tuning, 77% and 70%. We improved the model performance and reduced overfitting, but it is not a good model for us. After observation of XGBoost classifier, before hyperparameter tuning, train accuracy was 98 and test accuracy was 90. After hyperparameter, train accuracy was 100 and test accuracy was 92. Here I have made a mistake. I have to adjust this. Next, the observation of SVM. The train accuracy was 98.5, test accuracy was 89. After hyperparameter tuning, train accuracy is 98.3 and test accuracy is 97. SVM performed very well as compared to other algorithms. In terms of feature importance, RAM, battery power, pixel height and pixel weight are the important features. F1 score for individual classes is also very good. Area under curve for each prediction is also almost 1. So we will cross check whether the data is good for SVM or not. Here made a scatter plot. We will make a new test here where we will be storing X test. And as you can see the test here, that is this. We have reduced with 1000 columns and 13,000 rows and 13 columns, where before it was 2000 rows and almost 18 to 20 columns. So after concluding this mobile price range prediction using classification, supervised machine learning, we came to the conclusion. We started with data understanding, data wrangling, basic idea, where we found a relationship trend between price range and other independent variables. We selected the best feature for predictive modeling by using the K-based feature selection method using chi-square statistic. Implemented various classification algorithms, out of which SVM algorithm gave the best performance after hyperparameter tuning with 98.3 training accuracy and 97 test accuracy. XGBoost is the second best good model which gave good performance after hyperparameter tuning with 100% training accuracy and 92.25% test accuracy. Canon gave the very worst performance model. We checked the feature importance of each model. RAM, battery power, pixel height and pixel weight contributed the most with the price range prediction. So I have ended this project. Thank you.